Okay, Bismillahirrahmanirrahim. Okay, welcome back, folks. Okay, today we are moving on to the Edexcel Mathematics A paper from the 1 MAO syllabus. This is the 1H. This I'll call this the slightly bit more challenging paper. Some questions are challenging questions and a little bit more. This is the November. Okay, November papers are generally a little bit more challenging than the June papers, just to give you that bit of extra test. Okay, but we'll look at this paper inshallah. We'll see how many videos this takes for us to make today inshallah. Right, today this paper is a non-calculated paper, so folks, can you put your calculators away? Nimra, calculator, cap the calculator please, switch it off, turn it over. Okay, right, Isa, can you feed me some new questions? Alright, here comes the first question. Okay. Here are the ingredients needed to make 16 gingerbread men. Ingredients: flour, ginger, butter and sugar. Okay, we're making gingerbread men. Right. Hamish wants to make 24 gingerbread men. Work out how much of each of the ingredients he needs. Okay, so we start off with 16. And we need to get to 24. Okay, now, can we go from 16 straight to 24?
No.
Not really. Okay, 16, can we go to 8?
Yeah.
Can we go from 8 to 24?
Yeah.
Because this is using a ratio technique. So, 16, if you divide it by 2, will give you
8.
the ingredients for 8. And then if you triple that, that'll give you the ingredients for 24. So it goes, Hamish wants to make 24 gingerbread men. Work out how much of each of the ingredients he needs. So that's the technique we're going to be using, dividing by 2 and timesing by 3. So off we go. Now remember, this is a non-calculated paper. So we have 180. We divide that by 2 and time the answer by 3. Samia, are you paying attention?
Yes.
You are? So what's 180 divided by 2?
90.
And 90 times by 3. So that's 270 grams of what?
Flour.
Yeah, alhamdulillah. Okay. That's the flour one done. Now we have the ginger. Okay, so we have 40. We're going to divide it by 2 and times by 3 according to our rule here. That's the way we get from 16 to 24. 40 divided by 2 is? 20 times by 3 is? 60 grams of? Ginger. Okay, let me just make sure that's in the video. I'm just going to check the camera that we got it all in view. That's looking lovely. MashaAllah, it's looking beautiful. Good. Right. Right, next one we have 110 grams of butter. So we have 110. We divide that by 2 and times it by 3. 110 divided by 2, Nimra, is?
55.
55 times by 3 is?
165.
165. So that's going to be 165 grams of butter. Yeah, we know about butter now, yes. Yeah. Specialist butter. Okay, 30 grams of sugar. We do 30 divided by 2 times by 3. 30 divided by 2 is? 15 times by 3 is? 45 grams of sugar. Okay, is that all done? Do that. Nice straightforward question. Start of the paper. Thank you, Isa. Can you take it forward, please? Okay. Right, for the next question, we need to do a line of best fit. Okay, this is a bit difficult since my ruler is a see-through, but I'm going to try my best. Okay. It's too small. Okay, right, let's just have a look. Your one is a bit out there. So the one that you've drawn. That's not too bad. Okay. Okay, so just about that one. Okay, roughly speaking. Okay, here's my line of best fit. Okay, line of best fit should go through as many points as possible and be an average of the values of the points we have. Now, on this line of best fit, we need to work out, don't move the paper, I'll look at your question paper. It says what type of correlation does a scatter graph show? Question A. So this kind of correlation is called a
Positive.
Okay, positive correlation, that's answer A. Right, what's question B? You can't see it on the board at the moment. A different student in year 11 has a height of 148 centimeters. Estimate the arm length of this student. So 148, which is here. So, okay, now from our scale 80, each little square is worth 1. So you've got 80, 81, 82, 80, 83, 84, round about 81, 2, 3, 4. Okay, I'm getting an answer around about 84. Okay. Have you 84?
Yeah.
So the answer here, this answer here is 84. Okay, you got round about the answer? Because 85 is okay. The range of acceptable answers is between 83 and 87. You answer between those two ranges, then you find you'll get the answer for the on the marks. Good, lovely. Is that all for that question, Isa? Is there any more parts? That's it. Can you forward to the next question, please? Right, here is part of Gary's electricity bill. We got a little star there. The star indicates what?
Functional skills.
Functional skills. Okay. Here's part of Gary. That's the new syllabus that they're introducing now. So more kind of practical style maths. Here's part of Gary's electricity bill. New reading, old reading, pence per unit. Work out how much Gary has to pay for the unit of electricity he used. Now, if the old reading is 7095 and the new reading is that, what do we do with those two readings to work out how many units he's used? We have to do?
Add them up.
Minus them.
Why?
Okay, you minus them to work out the difference. Okay, if you add them up, you'll get some huge number. There. Okay, 7155 is the new one. That's the old one. You take them out to work out how much you've used in between the period. You definitely don't add. Let's just minus them right there and then. So that's 7155 minus 7095. 5 minus 5 will give you 0. 5 take away 9, we can't, we borrow from the 1. Comes 15. 15 take away 9 is 6. 0 take away 0 is 0. 7 take away 7 is 0. Okay, so if you have 7155 minus 7095, how many units do we have?
60.
60 units. Each unit is sold at 15 pence. So 60 times by 15. Okay, we gotta work that out.
900.
Okay, well we just do 15 times by 6. What's 15 times by 6? I'll give you 90.
Yeah.
And what do you add then?
0.
0. That answer is in
900.
pence. Which the answer is 9 pounds. Okay, Isa, you got that?
Yeah.
Good. Okay. Okay, next question. Okay, Alison wants to find out how much time people spend reading books. She's going to use a questionnaire. This is very similar to the paper we did on the day, yes?
Yeah.
It's literally exactly the same style of answer, yeah?
Yeah.
So how much time people spend. So do you remember the response boxes from there?
Yeah.
We had 0 hours, yeah? Okay, something similar to that? Remember that? So the question is identical. How much time do you spend doing an activity? So the question is going to be, we can ask the question, how much time do you spend just checking the video, making sure it's all in frame. Lovely. Okay, how much time do you spend reading books in a week? So we put a time frame on the question. Okay, we don't have any overlap on the boxes. Okay, good. Right, okay. You start taking it up, please. Did you text your daddy, sir?
Yeah.
Finish a bit later today. Okay, right. It says work out an estimate for 31 times by 9.87 divided by 0.509. So Isa, what do we round off 31 to? 30. 9.87 Nimra, what do we get? We round it off to 10. 0.509 Samir, what do we get? 0.5. So that's half, yeah? This is a nice, what we call them nice chunky numbers. Numbers are easy to deal with. So, Isa, 30 times by 10 is? 300. Now 300 divided by half, please nobody say 150. I'm going to jump out the window. 600 is correct. You get 600?
No.
Okay, when you divide by a fraction, the answer gets bigger. Normally when you divide by a number, your answer is smaller than what you started with. Because we're dividing by a number which is less than 1, our answer is bigger than what we started with. So one way of thinking about this question is I have 300 cakes, divide them into half. Okay, divide them into halves. How many half pieces do you have? 600. Okay, done? Happy? Good, let's move on to the next question. Okay. Okay, right. Isa, take it up just a teeny bit more, to 2 more. That's it, that'll do. I'll just relabel that Y anyway. Right. It says describe fully. What question number is this? Because we can't see the question number. Put that on the board. Okay, it says here describe fully the single transformation that maps shape P onto shape Q. What's your first idea, Nimra? What does it look like? Enlargement. Yes, it's getting bigger. Now to work out the center of enlargement, Nimra, what do we need to do? We need to find where the enlargement started from, yes? So what do we do? We've done this just recently, me and you, Isa. What do we do with this shape? We got to line up this point with its corresponding point, which is same point over there. Change color again. So this point will correspond to that point. So I'll try my best now to do these lines as accurately as possible using the technology at hand. Don't know how good this is going to be. Okay. Right, is that, yeah, I'll be happy. You got something similar to that? Isa? Okay, good. Right, let's do the second line. Different colour. Okay. Right. Have you got that, folks? Happy with that? These 2 points correspond, join in a straight line. Those 2 points correspond, join in a straight line, and the meet back up here. Where is the meet up? The origin. Okay. You don't need to do the third one. You just need 2. Because once you get 2 lines, you get intersection. They'll cross. If you do the third one, they'll cross in the same place anyway. That's not necessary. If you feel like doing the third one to make yourself feel happy, by all means knock yourself out. Yeah? Right, describe fully the single transformation. How many marks are we giving for this question? 3 marks, right. What do we start? We start with the word that Nimaz mentioned earlier. I don't have room to write on the bottom because my video stops here. So I'll write here. You write on the bottom, please. He says enlargement. What's the scale factor? Ooh, scale factor, I don't know that. Scale factor means we started here and we went to that one. Okay, what was the measurement here? This is 2, and now we have 1, 2, 3, 4, 5. Now, to get from 2 to 5, we have to multiply by 2.5. Okay, so the scale factor is 2.5. Now, the next part, the center of the enlargement. Let me just check that part of the video is actually it's on. Let's just hope that's on. Oh yeah, alhamdulillah, that's good. Center of enlargement. What is the center of enlargement?
Origin.
We said origin or 0, 0, whichever one makes you happy. Okay? Both of them will carry the same amount of marks. To get the 3 marks here, we will mention the word enlargement, scale factor, center of enlargement, we get marks. You must give that much information. Done that, Isa?
Yeah.
Okay. Okay, Isa, take us up, please. Quick. Squirty.
Why haven't we got number 7?
Is it number 7?
Right, it says yeah, 8 p.m.
Okay, right, okay, thanks, Dad. Thank you, Daddy. Okay, right, question number 7 on yours has gone on chutti. So you got question 7 on yours? Everybody ask question 7?
No.
Well, here's question 7, right? No, my question 7 is going on a holiday in your exam paper. Okay. For now, can you just quickly copy this down on a piece of on this paper here? Have a look, there might be something else in the paper.
It's not.
How do you know? Yeah.
Just trying.
Okay, so we've lost question number 7 from the students' worksheets. Smear, actually spent these ones here. No, I understand. The bottom ones are better, I think. Oh, that's been difficult. I'll let me just quickly check this one. Question number 9 is missing. Or 8.
I think there's 9 as well.
Yeah, Habibi. Right, use this one. It's a new one. These ones are better than new prints. Okay, we have another copy, folks. Sorry about that. A bit of a technical issue there. So you all use that paper, please. These ones are better. I just checked. They're all there. Right. Should we just quickly staple it for you?
Yes.
That's count 50 extra. Okay, folks, sorry about this delay. I didn't say Bismillah on the delay. There you go. It's all of them in there, yeah. That's the first one when you've done it. For some reason, something went missing on it. Okay, Isa, can you pass me yours, please? Thank you. There you go. Okay, are you happy with that, folks? Have you got it now? Right, sorry about that, folks. A bit of a technical issue there. We'll all sort it out. Alhamdulillah. Here's a diagram of Jim's garden. MashaAllah, nice big garden. Jim wants to cover his garden with grass seed to make a lawn. Grass seed is sold in bags. There's enough grass seed in each bag to cover 20 meters squared of garden. Each bag costs £4.99. Work out the least cost of putting grass seed on Jim's garden. So that doesn't, so for example, if you need 10 bags, it doesn't mean go buy 20. That's what it means. Buy 10. That's what we need. Okay, now, we need to work out the area of this shape. Can anybody remind me what is the formula for working the area of a trapezium? Okay. Area is equal to what? Remember, trapezium, right angles, these sides are parallel. Yes? You familiar with that? To work out the area. Okay. Okay, folks, welcome back. Right. We're just about saying question number 7. Here's a diagram of Jim's garden. This is the second video of this paper. we're looking at the shape of Jim's garden. It's a trapezium. We're told that he has to cover it with grass seed. Each bag costs £4.99. Each bag covers 20 meters squared. So this is a question that requires us to look at the area of his garden. His garden is a trapezium shape, and this is the formula for working out the area of a trapezium. A and B are the parallel sides, and H is the height, the perpendicular height. Okay. Right. Let's put these things in the formula. Ready? Yeah? Let's do the blue. So we said the area is equal to A, which is 12, and we're going to add the 18. And then we're going to divide it by 2, and then times it by the height. Height is 9. Okay, 12 plus 18 will give us a value of, folks. 12 plus 18, mental maths. 30 divided by 2, 15, then 15 times by 9 is what we're going to work out. So the area is equal to 15 times by 9, and that gives us an answer of
135.
oh, mashallah. Okay, good. So 15 times by 10 is 150, minus 15, that gives you 9. Yes? Happy, Isa? So we need 100, he's got 135 meters squared of garden. Now the bags are done in 20 meter squared bags. So what do we do now? We get the 135
Divided by 20.
and divide that by 20. Okay.
We need 7 bags.
Okay, so that will give you 6 points in the bag, yeah?
Yeah.
But we need 7 bags in there. Okay, so 135, if we round that up, say for example to 140, so do a quick mental calculation. We divide that by 20, that will give you 7 bags exactly. Okay, because that number is slightly less than 7, for 140, you'll need slightly less than 7 bags, but you can't buy slightly less than 7 bags. So you've got to buy 7 complete full bags. Okay, so we need to buy 7 full bags. Each bag costs £4.99. So you got £4.99 times that by 7. Well, what's £5 times by 7? That'll give you £35, and we have how many extra pence? 7 pence extra. So £35 minus the 7 pence will give you £34.93. Okay. Alright. So that should be the cost of, yeah? Do that? Okay.
Split up the shapes.
Okay, you can also split up the shape, make a rectangle and a triangle. That's also completely correct. Whichever way, whatever floats your boat. Okay, no problem at all. Right. Okay, is that it for that particular question, Isa? Is there any more?
Yeah, that's it.
That for that question, yes? Can you give me the next one, please? Okay, there are, right, question number 8, there are only red counters, blue counters, white counters and black counters in the bag. The table shows the probability that a counter taken at random from the bag will be red or blue. The number of white counters in the bag is the same as the number of black counters in the bag. Okay, so what we do first of all, let's work out the total that we have so far.
0.7.
So what is the probability, what's the total probability? The total probability of anything is always
1.
1. So if you already have 0.7 accounted for, how much is left over?
0.3.
0.3. Now it says here that the probability of getting a white and a black is the same. So this probability and this probability is the same. So you've got two same numbers added together give you 0.3. So what will they be then?
0.15.
1.5. You happy with that, Isa?
Yeah.
0.30, yeah? Okay. So Tanya takes a random account on the bag. Work out probability that Tanya takes out a white counter. Well, from the table. Okay, so the probability that Tanya takes out a white counter is 0.15. Okay, now don't move the screen up for the moment. The next question says there are 240 counters in the bag. Work out the number of, I think, How many more questions do you have on that page?
Just that one.
Just that one. Okay.
Just do an arrow and do it at the bottom.
Okay, right. I've only got this much part on the video. The next question is over here at the bottom. So let's just copy it over here. Okay, now. So the next part says there's 240 counters. Okay, in the bag. Work out the number of red counters. Right. What's the probability in a red one? 0.2.
Same as 20%.
That's right, so 240 times by, so that's how many you got. That's the probability of a red one. So that's 240, 20% of 240. 0.2 is 2/10, 20%. What's 1/10? 24. 2/10 is going to be 48. Lovely. Bit of mental maths there. Always healthy. So what did we say?
Red counters.
Okay, mental maths there. We said the answer was 48. So the number of counters is 48. And that's the end of question number 8. Hold on. Okay. So Isa, give me the next question, please. Alright, let me just double check on the video. Right, let's make sure the video is working good. Okay, it's looking alhamdulillah good. The diagram shows a prism. We have a height 7. First step is 2. Alright, let's just quickly put in some quick measurements. So Nimrod, that's maximum 7, that's 2. So what's the height of the second step? 5. Because 5 at 2 is? Good. This is 9. Isa, that one's 4. So what's that going to be? 5 as well. So he's putting in some bit of missing measurements. Okay. Let's look at the volume of the prism. Just one moment please folks. Okay. Okay. Now the volume of the prism, Nimrod, give me the general idea. The volume of this prism, the general idea for working the volume of the prism is we work out the area of the cross section and then we multiply it by the, in this case is the width, how thick it is, the shape. Okay, let's work out the area of the shape here. Right, what do we do here, Isa? How do we, give me that technique for working out the area of the L shape. Split it up into 2 parts, yeah? So, should we do... Right, so Isa here the length is 5 and the width is 2. So 5 times by 2 is? Okay, why have we done 5 times by 2? Because the area of a rectangle is length times by width. Length times by width. Okay, the next question, we can put this as our length, for example, that's our width. So the area equals length times by width. 7 times by 4, so that one's going to give us 28. So what's the total area then, Isa? We got here 28 and then we add another 10. That gives us 38. Right. So we worked out the area of the cross section. We now have to multiply it by, well, you call it how you like. You call this the width of the shape. Okay, or the length of the shape, doesn't matter what you call that. So we say the volume is equal to the area of the cross section time, I'm going to call it length. The length of the shape, how long it is, that way. That's our general formula for volume of any prism. So now we say volume is equal to the area of the cross section. Isa just told me the answer was 38. And we're going to multiply it by 10. So that gives me an answer of Isa 380. And the units are centimeter cube. Please do not miss out the units. I know the units already in the corner. That's good. That's lovely. They're already giving the units. That's question number 9. Right, let's go for number 10 now. Okay. Right. Okay, question number 10. We've got some slight technical issues with question number 10. We can't use this size on the board because none of the measurements will work. So I'm going to use now a scale size. I've also enlarged your sheets as well, so you can use this now, please. So use that. Right, let's have a look. I'm going to have to do on a scale size for myself. I don't know where's mine. Has anybody seen my sheet? Alright, thank you. Right, we're starting now, please, folks. Right, welcome back. Okay, so the question says here, we've got to find a distance less than 30 kilometers from Burford. The scale is 1 centimeter is 10 kilometers. So 30 kilometers will be how many centimeters? The scale is 1 centimeter is worth 10 kilometers. In the question we have 30 kilometers. How does 10 become 30? So we need, can you set your compasses to 3 centimeters, please?
This one, the way. Wait, okay.
Yeah. 3 centimeters, measure 3 centimeters. 3 centimeters from Burford. Well, this is hard and good. Alhamdulillah. I'm going to do that bit block in a second.
How do you do this?
How do you do it? Put your pencil in there first. Put your pencil in there. Come on. Come on, do it. Put it in there. Open it up.
You just pull the sheet.
Okay. Do it like this. Like that. There. I measure 3 centimeters. On here. On the tippy tip. Yeah. And then draw me a nice circle. Okay, as you can see, I've just drawn a circle at 3 centimeters. You can't see that on the video. I'm going to do that a bit darker now. I'm going to borrow one of somebody's felt. Is there a felt pen, yes, ma'am?
Yeah.
Need a felt pen to enhance the video. I got one for you. I'm going to do this freehand. It goes, it's going to be less than 30 kilometers. So can you make the line dotted, please? So this circle here has got a radius of 3 centimeters. And I've gone over it now in a felt pen. And I've done a dotted line because it was less than, so the 30 kilometer radius is not part of the solution. Okay. Right. Next part of the question says that it must be less than 50 kilometers from Hightown. Now, 10 kilometers is 1 centimeter. To get to 50 kilometers, we need to multiply by 5. Time by 5. Time by 5. So we need to set our compasses to 5 centimeters. Okay. Let's take the 5 centimeters here. I'm trying to do what we do now. Okay. Okay. I've got 5 centimeters. Right, we got 5 centimeters done. So, okay, Bismillah, let's see if we can get it done.
You done it.
Oh, slipping a bit. It's difficult on the board. Okay, I've got my 5 centimeters now, that's 50 kilometers. Okay, folks, can you do that one as well, please? 5 centimeters now. You should have a nice area of overlap. I'm going to use a different color now for that. We use blue. Now we're going to use brown. And again, because it was less than 50 kilometers, I'm going to make it dotted. I think the brown is a bit lame. Alright, let's try a different color. Black. Okay, let's try black. Okay, as you can see here, for completeness, even though it goes off the, it goes actually out of the map, that part, this part here. Don't worry about that for the moment. So shade the region of the map where the company can build the warehouse. It's got 2 conditions. It's got to be inside the blue circle and also inside the brown circle, so where they all both overlap. So our answer is going to be, we do in red. Okay, Isa, you got that?
Yeah.
Is that making sense, the question? Nimra? Can you shade in the region? Please can you make sure that your dots, your circles on the examination question are dotted? That's okay? Let's go to the next. After you finish that, please let's move on to the next question. Okay. Okay. Right, expand. Right. Ladies, can we finish the compost drawing now, please? Can we finish it? Come on then. Let's make a move. Okay, so are you ready for the next question?
Yeah.
Just waiting for these girls, you know. Super fast coaches. I said you don't do that, I'm scared. Okay. Right, we are now ready to move on to the next question. Thank you, Nimra. Right. We will need to expand this single bracket question. Okay. Let's see if make it a bit. Go to next country. Oh, that looks more juicy. That's good there. That's nice. That's a in there.
So maybe right.
It's okay. It's okay. Let's expand this. We have a single bracket. Isa, what's between the 4 and the bracket? There's an invisible what? Times sign. So we have to now multiply everything by 4. So we have 4 times by 3x and 4 times by plus 5. 4 times by 3x will give us an answer of 12x. 4 times by plus 5 will give us an answer of plus 20, not 20, plus 20. The sign between the two numbers comes from the question itself. 4 times by plus 5 is plus 20. And that gives you the answer there. Okay, next one. Right, we don't need to move up for the moment. Expand and simplify. So we have a single bracket and another single bracket. Right, let's multiply them out in a similar fashion. So we start with the 2. The number outside is the multiplier. So we do 2 times by x, which will give you 2x. We do 2 times by minus 4, which gives you minus 8. Okay? Then we have, change color. Then we have plus 3, that plus belongs to 3, plus 3 times by x, plus 3x. We have plus 3 times by plus 5,
Plus 15.
Okay, lovely. Next, now that we've got our 2 separate parts all multiplied out, we need to simplify the second part of the question. So we'll collect like terms. So we have 2x and another 3x, that gives us 5x. Okay, we have a minus 8 and a plus 15. Nimra, that gives us
Plus 7.
plus 7. And we are done. Okay? I need you to feed it up, please. All the way up. That's lovely. Right. Let's have a look. How's it coming up in the question? Bring it down just a teeny bit from the top, please. Just a teeny bit down. Down. That's a little bit. Expand and simplify. Now we have double brackets. The way we deal with double brackets, we start from the first item in the first bracket and we multiply by each item here. Then we go to the then we go to the second item and we multiply that by each item. So let's do the color coding. X times by x is?
X squared.
So you have x times by plus 6.
Plus 6x.
Okay, let's change color. So you have plus 4 times by x is?
Plus 4x.
Plus 4 times by plus 6.
Plus 24.
Okay. So it goes expand, we have expanded. Okay, not us physically, otherwise it's too fast. But there we go. X squared.
Plus 10x.
This part will simplify, give us what?
10x.
6x at 4x will give you The expert doesn't simplify because there's nothing else to simplify with. No, the 24, that's the only number that we have there. And these become 6x at 4 gives 10x. Okay. Any more on that question?
No,
Isa?
that's it.
No more, because I can't see the rest of the paper. Okay, right. Go for it.
So zoom out.
Let's have a look. One second. No, leave it out, that's fine. The diagram shows a circle drawn inside a square. Okay, good. Zoom out just one notch. That's lovely. At least I can. Right, okay. I think you can see everything, even the bottom part. Yeah, just do that. Second. Yeah. Right, because the diagram shows a circle drawn inside a square. The circle has a radius of 6 centimeters, which is here. The square has a side of length 12 centimeters. Remember, it's a square, everything is 12. 12 here, 12 there, 12 here, 12. Okay? Work out the shaded area, give your answer in terms of pi. Okay, so let's see what the. Now, what is an idea? I want somebody to give me an idea how we're going to work out that little corner there. What do we do? Ladies, any ideas?
6 times 6.
Okay, well, just give me an, don't give me the numbers, just give me an idea. I want to do this first, and I want to do that, and then I'm going to add them, I'm going to divide them, and then that area will give me this, and that'll give me my answer. Give me like a general kind of idea on how we're going to do it. Okay, go on. Think about it first. Nimrod, give me your idea.
My idea is
Okay.
find out the area of the circle.
Find out the area of the big shape outside. Yeah, well done. Yeah. And then
And
we minus the area of the.
circle.
Good. You minus the area of the circle. What will that give us? That will give us the area of each. That will give us the area of 4 shaded parts. What is it? Then divided by 4. MashaAllah. Alhamdulillah. That's the idea. Area of the big shape minus area of the inside shape. That will give us the 4 internal shaded parts. We only want 1, so we divide by 4. Is that okay? Yeah. Okay. Right, let's go for it. Area of the square. Area of the square is length times by width. Okay, 12 times by 12. And the area of the circle is going to be pi times by the radius squared. Okay. Okay, what's radius squared? So it'll be 6 squared, yeah? And then we'll divide it all by 4. Okay, 12 times by 12, Mr. Isa, it will give us an answer of?
44.
Yeah, and 6 squared gives us? 6 squared will give us 36, times by pi gives 36 pi. We are not going to work out it numerically, we don't give it on a calculator. This is a non-calculator paper and they want the answer in terms of pi anyway. We are not going to do mad stuff like multiply by 3/4. That's just crazy. Then we divide it by 4. Okay. Now, can we factorize that and get rid of this 4 on the bottom? Can we simplify that a bit more? Because we need to simplify this. Because we can't do that thing, right?
Yeah.
So can we take out 4 from here and 4 from there? Can you get a 4 out from 144?
Yeah.
Yes.
Yeah.
Right. So 144, you divide it by 4, 0, 1. How many 4s in 14? 4 times by 3 is 12, remainder? 2. 4 to 24 is?
No, 1.
4 to 24 is? 6. So if you factorize this, this will be what? This will be 4 times by 36 minus 36 times by pi. Okay. What are we going to pull out? Should we refactorize this 36 here? Because I got 36 in here as well. Because we want to put the 4 out to cancel the 4 on the bottom. So let's get rid of this 36. Can you pull out 4 from 36? What do you get? How many 4s from 36?
9.
9. Good. So that 36 can be factorized like that. Now we're ready to pull the 4 out. Okay, if you pull the 4 out, what do we have? 4 bracket 36 minus 9 pi divided by 4. Are you happy with that, folks? I've just factorized, I've split up into factors, pulled the 4 out, and I'm left with that so far. You got that, Imran? Are you happy with that, Isa?
Yeah.
So what do we do now? We opposite of time by 4, this and that will cancel, because you divide that by 4, divide that by 4, they get rid of each other. So the answer should then be, final answer, question number are we on, Isa?
12.
Oh. Okay, are we happy with that? And what was... Okay, I'm okay with that. Right. Okay, we're gonna break in about 20 minutes. Okay, then we'll do the rest of another lesson. Right. The key part of that question, Isa, is the idea. It is the outside shape minus the inside shape, then we'll give you the 4 bits,
Yeah.
but we only want 1
What?
to find the answer by. So the idea is correct, the rest of it is just put the numbers in there, multiply it out, simplify it, factorize, and you're done. If you don't have the right idea, you're going to be on a high place, high cliff, ready to jump off. Okay, Isa, are we ready to move forward? Ladies, are you finished?
Yes. What is it to say no?
That's funny, yes. You're funny, you are. You're very, very funny. Okay, we're going to start next to this question, so that's telling us it is a functional skills question. Okay. Talil or Talil is going to make some concrete mix. He needs to mix cement, sand and gravel in the ratio 1:3:5 by weight. Talil wants to make 180 kilograms of concrete mix. He has this much ingredients. Does he have enough to make the mix? So, first of all, let's work out how many parts we have.
9.
Add up the ratio. So 1 at 3 will give you 4 at 5 will give you. So we have 9 parts. We need to make it all together 180 kilos of mixture, yeah? Mixture. So if we get the 180, we divide it by the 9 parts, then we know what each part should be worth. What's 180 divided by 9? 20. So 20 kilograms per part. Right, and let's work out now how much of each part we need to see whether we got it or not. So we have here at the moment 1:3:5. Is that the ratio? So you got cement, sand, gravel. Cement, sand, gravel. And we know that each one of these parts is worth how many kilograms? Times by 20. So, Isa, what is 1 times by 20?
20.
Really hard question. 20 kilograms. Samia, 3 times by 20.
60.
Nimra, 5 times by 20.
100.
Okay, so in order for us to make our 180 kilo concrete, we need 20 kilos of cement, 60 kilos of sand, and 100 kilos of gravel. Now look at the ingredients they're giving you. We need 20 kilos of cement. Do you have 20 kilos?
No.
No. 15 kilograms is not 20, so we don't have enough. We need 60 of sand. Do you have at least 60 of sand?
Yes.
Yes, that one looks good. Do we have 100 of gravel?
Yes.
Yes. But the question says that does Talil have enough cement and sand and gravel to make the concrete mix, and the answer is no. So he hasn't got enough of this, so he can't make it. So the answer is no. Okay, so Talil does not have enough what?
Cement.
Cement. He is 5 kilograms short. Done. Happy? So that's a question that requires us to do a ratio question and then to reason with the question to say no, we can't do it. Alright, here we go. What question are we? Can we move up to
14.
question number 14 now, please? Okay, question number 14. Does that make sense? Oh gosh, God help us. Okay, the next question, let's have a look. Okay.
That's it.
Okay, the bearing of a ship from a lighthouse is 50 degrees. To work out the bearing of the lighthouse on the ship. That we should be able to do on the boat. Sure. Okay, we have a ship. The bearing of the ship from the lighthouse is 50. So The lighthouse, we put the lighthouse here. Lighthouse. Okay, right. When we do bearings, how do we do a bearing question, generally speaking? We always start from north. Okay, so we always start from north on a bearing question. And he said the bearing of a ship from the lighthouse is 50 degrees, 50 degrees, if I say something like that. I don't want to use this. Okay.
Oh gosh, gone right.
Okay, right. What we do not need to draw this shape to scale, but for the sake of this question, we give learning some extra skills. Now we have to work out the bearing back to front now. To reverse the question. This is the lighthouse and the ship is on this bearing. Just as an example, for the sake of argument, the ship is here. It doesn't matter where you put it. Okay? Now I need you, Isa, give me another notes line here, please. Now the question says here, work out the bearing of the lighthouse from the ship. So now we're going to start the question at the ship and work out how do we get from here to here. So what we need to do in that case, we need to start at the ship, because it goes from the ship start here. We face north and we go all this way until we are facing now the lighthouse. Okay, from the question you can see this 50 here is the same as
That 50.
this 50 here. Why? Because we have parallel lines. The north lines are parallel lines of both north. Both perpendicular to each other. Okay? So these are parallel.
Yeah.
So that's 50 now. Isa, what's this one part going to be?
180.
180. And we need to go all that way. We need to go the 50 way and the 180 way. So we got 50 and 180. That'll give us an answer of what?
230.
So the bearing of the lighthouse from the ship is 230. That means you are at the ship. You're facing north. You're going to turn all the way around 230 degrees to be facing the lighthouse. So that's we're done. So for that one there, we didn't actually need to do an accurate measurement of the angle. I just wanted to show you do that one anyway. A sketch would have done the job. Okay? Alright, have we finished all that question?
Yeah.
Is that the normal part of that question? Okay, good. Isa, can you make this one slightly bigger, please, if it's possible? Go up one more notch. Oh, that looks lovely. Okay, right. Simplify m to the power of 5 divided by m to the power of 3. Nimra, when we're dividing indices, what do?
We take them away.
These are the same, so we take away the plus of m. 5 minus 3, that gives you m to the power of 2. Okay? Right. Next part, simplify this. What we can do here, first of all, rewrite it, put in the multiply signs. Okay, there goes the doorbell. Okay. Right. What I've done here, I've expanded all the term there, put the time signs in there. Now when we're doing times, can we change the order?
Yeah.
Yes. So let's change the order, put all the x's together and the y's together. Okay? So we'll rewrite it as x to the power of 4 and times by the x to the power of 2. Put that in one colour. Let's change colour now. Times by y to the power of 3 times by y and we leave the 5 as black. 5. Okay, so we've got 3 different colours there. One colour for the number, one colour for the x's. I've got the x's powers right here.
Yes.
And one colour for the y's. Yes, alright, powers. Okay, let's start simplify these. So the 5 stays as the 5. We have x to the power of 4 times by x to the power of 2. When we have these bottom numbers here, the base thing is the same, the base part. What do we do with the powers? Add them. So that'll give you x to the
6.
4 and 2 is 6. Okay, Nimra, y to the 3 times by y to the 1. There's a 1 there, automatic. What do you do those? Add them. Because we multiply these, they're both the same. Add the top ones. Are we finished?
Yep.
Done. Okay, lovely. Isa, you got that?
Yeah.
Okay, let's stop it off and go on to the next question, please. Can we give me the next question? Ooh, nice question. Okay, the diagram shows a triangle. In the diagram, all the measurements are in meters. The perimeter of the triangle is 56 meters. The area of the triangle is a meter squared. Work out the value of a. So, it says the perimeter is 56. We need to form an equation for the perimeter and hence work out the value of x. Okay? So, first of all, they told my perimeter. So, Nimra, let's start here. What does the word perimeter in this situation mean? What are they talking about?
Outside.
The outside what? Length. Outside length. So is this length add, this length add. Okay, let's add them up. So we have x minus 1, add 3x plus 1, add 3x. And all of that must give you a total of. So what's x add 3x add 3x? 7x. What's 1 minus 1? Nothing. Nothing there. Okay. So 7x. So when we add all this up together, the algebra, this, add this, and minus 1 and plus 1 cancel out, and we're left with only 7x, which must have a total of 56, which they gave us in the question. So what is the value of one of the x's?
56 divided by 7.
Opposite time by 7 is?
Divide.
So x is equal to
8.
8 centimeters. Is it centimeter or no?
Meters.
8 meters. 8 meters. Okay? Now that we know x is 8 meters, we can substitute x equal 8 meters into here. 3x. 3 times by 8 is equal to 24 meters. We can put 8 into here. We have 8 take away 1. 8 take away 1 is
7.
8 take away 1 is 7 meters. Okay, so we have now, by working out first of all the value of x from the perimeter, forming an equation, the perimeter, working out the value of x, we can now substitute the value of x equals 8 back into here. 3 divided by 8 is 24. 8 take away 1 is 7. Now we have the base as a number, numerical, and we have the height as a number. Now, Isa, remind me, what is the area for a triangle? Area for the triangle is equal to?
Base times height divided by 2.
Good. So the base is 24. And the height is?
7.
And we divide it by 2. Now, 2 divided by 2 is 1. 24 divided by 2 is 12. So I'm doing a bit of house tidying, keeping it all simplified. So we end up with 12 times by 7. 12 times by 7 will give us a total of. Okay, you don't need to whisper this, man. So we'll work out the value of A. So A is equal to 84 meters squared. And that is the end of question number 16. Okay, we've got a few minutes left before we round up this lesson, and we'll have to continue in the next. Right. Okay, Mr. Isa, can you give us the next question, please? Oh, lovely. Isa, I think you have to reduce it on, please, the size, because we can't get on the screen. No more. That's lovely. Okay, let's just make sure that's actually all on the video. Don't move anything at the moment, don't move anything. Okay, no, it's not all on the video. Okay, y equals x minus 2 is there labeled, x plus y equals 10 is labeled. Okay, just physically move the graph up using the curve, using the up a bit more, up a bit more. That's stop right there, that's bang on. We're back into the video now. Okay, that will do. Let's read the other parts for me. Okay, right. Read this part to me in the bottom, read what to say.
On the grid, mark with the cross X each of the points with integer coordinates that are in the region defined by
Go on.
y greater x minus 2, x plus y lesser 10, x greater than 3.
Minus 3.
Greater than 3.
Greater than 3.
Okay. Right. Let me just double check those on your thingy. So you have y is greater than x minus 2, x plus y is less than 10, x is greater than 3. Okay, dokie, right. So we have to now, this says shade the region.
Yeah.
What says?
Cross.
Huh?
Mark a cross.
Each of the points integer coordinates. Okay, let's just work out region first, yeah? And then we mark it across. Now, let's have a look at the line y is equal to x minus 2. Y equal to x minus 2 is this line. It says y is greater than x minus 2. So if it's greater than, is it above the line or below the line? It's above the line. For the moment, I'm going to suffice by saying everything which is above. Okay? Happy with that? Different color now. That's the first one done. Okay, in purple actually. Right, next one, x plus y is less than 10. Well, this line here is the line x plus y equals 10. It says x plus y is less than 10. If it's less than 10, it's got to be below the line. So we can use now a brown color for that. I'm going to indicate. Okay, now, a bit of technical idea here, by the way. Because it says greater than, technically this line should be dotted. Okay? And that line should also be dotted because it goes as less than and greater than. So, so the line should be solid. But for the sake of argument, for the moment, we don't need to worry about that because the question won't involve that. It's not about regions, it's about coordinates. So we'll get away with it for this particular question. But really should be dotted. Next it goes, x must be greater than 3. Is that line drawn on there, by the way? Third line?
No, just 3.
No. In order for us to know when x is greater than 3, we need to know when x is equal to 3. So where is x equal to 3? Let's change color again. X equals to 3 is physically there, that is, but it's also right. X equals 3 is actually a vertical line. The x-axis is horizontal. Why is that? That's how it is. Because on that line, x always has a value of 3. So for example, if I had a point here, that point would be 3 and 5. But the x value is always 3. So the x equals 3 line, the x family is all straight lines. Okay, let's go to that point. So now, I'll put that line dotted to be correct because x must be greater than 3. So that means is it on the right hand side or the left hand side? On the right hand side. Okay, now, I would like you to tell me which part of the graph now has all parts on it. Have I got the colour? No? Oh yes, we do. Oh, we have green. Right, Nimra, which part of the graph has got all 3 arrows in it, all 3 coloured? From here to here to here? Yeah. Okay, so from here to here to here, I'll just put a little kind of green triangle on it. Okay, that green triangle contains all 3 arrows, yes? So these 3 conditions are satisfied in that region. Are we happy with that?
Yeah.
Good. Alright, let's get rid of these arrows for the moment because they're going to distract us for the moment. We know that the arrows are there. Right. I want you to read that part again, Isa from the bottom. What does it say about integer values? Read that part again, please, Randy. So on the grid, mark with a cross each of the points with integer coordinates. So we are looking for not just the whole region, any space. We're looking for spaces that got integer means whole number. So for example, we're looking for corners, the grid. So for example, this one here, this one, this one. Now remember this, y is greater than x minus 2, so the actual line is not part of the answer. So you cannot put coordinates on the line, because it's got to be greater than, not equal to. So for that reason, this line here is not available for us to cross. So that's correct, that's correct, that's correct, and that is also correct. And also we said, x plus y is less than 10, so it's going to be below that line, but not including that line. So Isa, we can't put a point there, that'd be wrong. We can't put a point, that'd be wrong. We can't put a point there, that'd be wrong. Okay? That's not a point by there. It's just a corner. Okay, now, it says that x must be greater than 3, so we can't put any answers on the red line either. Is there any other space that we could put a cross on? That would be an integer value, but it's not on the red line, not on the black line. On the black line, there's no more, is there? No. So we should just get 4 points. So it says mark with an X. Done. That's the answer, done. So here they're not asking for a region, they're asking for coordinates. So it's like a variation of the question. So what are the coordinates? We've got 4, 3, 4, 4, 4, 5, and we've got 5, 4. Okay, you happy with that? Yeah. Nice, bang on the money. We have. Alhamdulillah. Okay. Okay, this is no long. No reason. Okay, I think we've come towards 7:57. Let's have a look at the next question, see how big it is. Okay, now I think we're going to stop there. Okay, folks, thank you for joining us. I think this is video number 2, wasn't it?
Was it?
Yeah, because we had
Yeah, 2.
Okay, folks, we'll see you in the next video. We'll know exactly at the end of how many videos it's taken, then we'll number accordingly. So don't forget, this is the Edexcel November paper for 2012, the 1 MAO syllabus, and this is the second paper, the first paper, which is the non-calculator. Okay? Inshallah, until the next video, please hopefully you benefit from these videos with your examinations. Inshallah, see you in the next video. Assalamu alaikum. Video. Lovely. Bismillah. Okay, folks, sorry we had a battery failure then. This is video number 4. Okay, Isa's tried the second part of the question by changing the plus into a minus. He had a math error. Because on your calculator, you have one minus is like this, and the other minus is the normal one. Okay. So the naked eye, they both look the same. Do not use that minus, that will give you the math error. That's why I say to you here, the secret of this quadratic equation is being really confident on the calculator. It's not about how easy the method is. You've got to make sure you don't make a mistake how you enter the values in the calculator. So that minus is out, the one with the brackets in it, and which is at the top, and the normal standard minus is in. So please don't use that one, you get math error, and that's the correct one. Once we've done that, we've got a correct answer of minus 0.3874, and we round that off to 3 significant figures. First, second, third significant figure. That's less than 5, so leave it alone. Job done.
That's the actual answer.
That's the answer, yeah. That's the final answer. Come on. Okay, I'm going to rub this off. Isa, you got that down?
Yeah.
Okay, I'm going to rub this off. And I want you to deliver for me, please, the next question. Okay, right. Okay. What's the number 23?
Yeah.
Max wants to make a random sample of students from his year group. Explain what is meant by a random sample. Okay. What is meant by a random sample? So each member of the population has, okay, no come in here, no come in here. Hey, you've been in the video. No, we'll give you a second. Move out of the way. So each member of the population has an equal chance been selected. Solid, saying something. Yeah. Okay, we're happy with that. Let's try this new one. Okay, you got that?
Yeah.
Right, describe a method Max could use to take his random sample. So he's doing for a year group, isn't he? Okay. Okay, describe a method Max could use to take his random sample. So what could Max do? So Max could number each member. Now what year group is he taking off? Is it year 9 or something? Sample of his year group. Okay? So Max could number each member of his year group. He could then, what could he do then? He could then use the random, okay? He could then use what? The random sampling button, yes? The random select button of his card. The screen. Okay. Right, are you happy with that, Lisa?
Yeah.
Have you used the random select button on your calculator before?
No.
No? I'll show you in a second. Okay, I'll show you. There. Shift random. That one there. That generates numbers. So that would be the first one is 38. Press it again, gives you another number. That's 60.
Alright.
So it'll be shift. Okay. For those of you who are not familiar with the button that you press on this calculator, you press shift and then you press the button, the point in it, and above it it says okay, and that will give you, like I've got here 0.606 and in the calculator display, so that means you would select, for example, candidate number 60, okay, the first two digits, or candidate number 60 because that number. Alright, so use that. Keep on pressing that button until it matches you. Okay, lovely. Right, let's move on. Okay, so really big.
Did you say it's 150?
Okay. Sorry, no, we'll cope. Okay, that's lovely. Yes, you can take up just a teeny bit more if you can. That's it. That's right. Just make sure. The table below shows the numbers of students in 5-year groups at a school. Okay, year 9, 10, 11, 12, 13, and the number of students. Lisa takes a stratified sample of 100 students by year group. Work out the number of students from year 9. How many students are there in year 9?
239.
So it's 239 out of the total sample. Can somebody calculate that for me, please? Can you add them up? Okay, folks, can you add that? Isa, can you add that for me, please? Okay, Isa, what number are we now? 23B, yeah? What do you guys total? What's total, Kismia?
1,140.
That's lovely. 1,140 is lovely. Okay, 1140. Okay, right. Just give me one moment. Paper. It's working. Come on. It's running. Working. Okay. Right. So that's the year 9 group. That's the total sample, and that's the stratified sample. Okay? So your selected group divided by the total sample size, and you multiply by the stratified sample size, stratified. So that's what all those things correspond to. Right. Who's got an answer for me for that?
I got 20.9649.
Okay, Samia's got 20.
0.9649122.
Okay, what you got? Isa? 96, yeah? Okay, good. So that gives us an answer of 20.96 something. Now, can we pick 20.96 people?
No.
So what should we say the answer is for this question then? 21. So the final answer is 21 students will be the stratified sample for year 9. Okay, right. Lovely. Are you happy with that? Got that done?
Yeah.
Isa? Smia?
Yeah.
Okay. Set up another student. Come on, join us. Nimraz, come on, join us. Okay. Right. Right. Okay. Right. Can we move to the next question, please? Some big fat questions you got there. Do you see one? Wait. The whole lemon. Up a bit. Take up. And can you actually reduce the size of gold and minus a bit? And just maybe. That's beautiful. That's beautiful. Just take it off now. Okay, let's just make sure that's also still in the camera view. That's looking nice and clear still. Okay. Don't forget we can only record it there. Fine. Right. Okay, Nimra. Right. What we're going to do for you, Nimra, let's give you some paper. I don't know whether the paper is at the moment. Huh? Yeah. Oh, I think here's one. Okay. Right, question number 24. How many questions you got left? Isa, is that the last question? You got a few more left?
3 left.
Okay, right. After this paper, we'll finish inshallah. Prayer break, asal inshallah. And then we'll come back and do another paper. Okay? Right. ABC is a triangle. A, B, and C. A to B is 8.7 centimeters. That's 64 degrees, which is angle C, and angle B is 49 degrees. Okay, in the format of the question it says angle ABC, which means A to B to C, the angle in between. That's what it's talking about. That's the angle language. Okay, calculate the area of the triangle ABC. Now, if you flip to the front of your papers, folks, flip to the front of your papers, there will be a formula for working out the area of a triangle, which is a non-right angle triangle, and that is area equal to half AB sin C. Okay? So this is the formula that we use to work out the area of non-right angle triangles. Working out the area of a right angle triangle is quite straightforward, base time by height divided by 2. This is not a right angle triangle at all, as you can see. Right. So that's 64 and 49 Nimrod. How do we work out that angle there, just for the sake of completing the diagram? What do we do to work out this angle here? Someone work that angle out. What do we do?
Tan 61.49.
Okay, and then minus it from...
180.
Okay, let's do the calculation first. Let's do 180. Quickly do that for me, please. Minus 64 minus 49. Type in as you see on the board.
67.
That gives us an answer of
67.
67. Now, in order for us to use this formula, okay, we need to know what? We need to know this side here and this side, which we do. And we need to know this angle here, which we do. Because this formula works on the basis that you know the two adjacent sides. So we know this side and this side. Hang on a second, my little son's joining us. What's his name? Shh. Quiet. Let him make a video. Okay. So the A and the B corresponds. Okay, not necessarily to our A and B. So what I'm going to do, I'm going to rub out their labeling and relabel the triangle. As I said to you before, make the labeling of the triangle suit us, suit our formula. So for the sake of argument, shh. Don't come back inside now. Right, let's get rid of this. A for the moment. So I'm going to draw the triangle. Now, half AB sin C. So the angle that you need is C. So this, I'm going to call this angle here big C. And this will be my little c. And I'm going to call this one my big A and my big B. So that's going to be my little A and that's going to be my little B. So far, it's very good. What do we know? We know from the formula, we know we don't know A, we do know B, and we do know that, and we know what the half, that's just a constant. So we need to work out the A. Okay? Now how do we work out the A? Now that we've got to the angle, we look for, we call it pairs. So, 49 degrees, that pairs up with, come again, yeah. Regina? Okay, sorry about that. Right. This 49 links with this one. That's one pair of information. Let's find another pair. Okay, we have, I call these dumbbells, okay, to join up together, make pairs. So do we know this pair completely? Yes. Isa, do we know this pair completely? And the answer is no, because we know the angle but we don't know its side. So what rule do we use for that? When we have one complete dumbbell complete, so we know the side and we know the angle, that's one complete piece of information, corresponding angle and side. This one we know the angle but we don't know the side. Which rule do we use? We use sine rule. That's it. Okay, we use sine rule. Okay, sine rule says we have A over sine of A is equal to B over sine of B. We only need to use the first two for the moment. Just start putting the values in straight away and rearrange it. So now A we leave as A, because we know what it is. The sine of A is the sine of 49 degrees is equal to B, which is 8.7, divided by its corresponding angle, the sin of 64. Okay, I'll stop there for a moment just to give you a chance to copy that down. Okay, Isa, do you know why we use sine rule? No. Okay, we use sine rule because we know one complete set of information, an angle and a side, one complete set. And the second set of information, we know this but we don't know that. So we know three things and we don't know one thing, three ticks and a cross. So in this particular situation, we use the sine rule. We have that kind of situation. Okay, if you look back at some of my older videos on YouTube, you find the rules on when we use sine rule, when we use cosine rule, and that'll give you more detail. Okay, but in this particular circumstance, we definitely use sine rule. Okay, now we're going to look at A. So Nimra, what do we do with the sine 49 on the bottom? I want to make A the subject. So how do I do that?
You take to the other side.
You take what to the side?
Okay.
You take the bottom, the fraction, the denominator. Opposite dividing by sin 49 is 2. So let's write that down again. Sin of 49 divided by sin of 64. Okay. Right, next calculator time. Grab your calculator. Don't know what you're waiting for. Throw it into the calculator. 8.7. Make sure you put a times in there as well, please. 8.7 times by sin of 49. On the bottom, use the fraction button as well on these new calculators. Very good.
7.3.
Okay, A is equal to 7.3. Okay, yeah. Isa, let's have a look at your calculation.
0.3, so
Okay, can you give me a bit more accuracy? Yeah, what do you got?
39.
Let's have a look what your calculation says. 7.30531, yeah? Okay, leave that calculation in your calculator for the moment. I'm just going to double check that we got everything in view on the camera. MashaAllah we have, Alhamdulillah. Right, okie dokie folks. Are we happy with that so far? So what we've worked out the missing link. We need the A to use this area formula. Are we happy that we've got the A value? Don't touch the calculator because we're going to reuse that value, that exact value. So don't like press 0 or equal or something or do something daft. Right. Okay, let's move on back onto this formula now. This is the area formula. So let's start putting this value here, feed it back into there. So we say, okay, area is equal to half times by the A. A is equal to, for the sake of the screen here, the video, I'm just going to put 7.305. You're going to use the actual, your calculator display in your calculation. But for now, this will do it for here. And then times it by B. What's our B value? The B value is 8.7. Times it by the sin of C, which is 67. Okay, right. Now that all the values are in place, we know the A now from that calculation. We already had the B, we already had the C. Throw everything into the calculator, please, folks. Take care with the calculator usage. Right, Nimrod, you guys would have done that?
Yeah.
Okay, Nimrod, what kind of answer you getting? I'm just looking at Isa's, what he's got for his. So Isa, what have you got for yours? Have you put in yet? Come on, put in. Okay. So Nimrod, what have you got for your one?
29.25191267.
Okay, right. And do you recycle that original value? Did you put that one back in, the original one? Okay, so let's have a look. So Nimrod's time you have area is equal to, say that number again please.
29.25
29.2
25 19
19
12
12 and so on and so on.
67.
Okay, right. It goes calculate the area of the triangle through three significant figures. Okay, Isa, do you have that similar number? Yeah?
Yeah.
Okay, so you got the same number? Good. Okay, so what we say, I'm going to change color now. Area is equal to three significant figures. First significant figure, second, third. Okay, that is 5 or more, add 1. So it becomes 29.3. The area will be... Okay. The question was a bit long. Yeah? The question, we had to first of all think what formula we're going to use for the question. We have to go away and work out the A value, come back and then work out the area. Call these questions goal problems. Okay, it's a goal. So you've got to go and achieve something first in order for you to do the question. So you can't just straight away do the question, you've got to go and work something else at first. Okay? Are we happy with that? It's all done? Good? Okay, Isa, can you deliver to me the next question please? Oops. Okay, these. Right. Okay, we're nearly towards the end of the paper. I think we've got just one more question after this. Alhamdulillah. Okay. Right, Carolyn has 20 biscuits in a tin. She has 12 plain biscuits, 5 chocolate biscuits, 6 ginger biscuits. Oh, they're my favourite. I love the ginger biscuits. Okay. Carolyn takes at random 2 biscuits from the tin to work out the probability that 2 biscuits were not the same type. Okay, now, if we work out the probability of getting the 2 biscuits the same, and we minus it from 1, we'll get, this is the quickest way of working it out. So, work out the probability that 2 biscuits were not the same. So, probability of not the same for the calculation is 1 minus the probability that they are the same. So that's the opposite way of doing it. Now, because the probability of them being the same plus the probability of them being not the same will equal to 1. Okay, it's like the minus 1 rule. So let's work out the probability. To do this question here, we'll do it in reverse. We're going to work out the probability of getting the same biscuit twice. And then we're going to add that up and minus from 1 to give us the actual answer they want us to work out. Okay? Right. What's the probability of getting a plane and the probability of getting another plane? Okay, first of all, how many biscuits are there altogether? 20. So probability of getting plane is going to be, first of all, is going to be 12 out of 20, and means? And means and. Times. And means time the probability. And what's probability of getting the second one? Now, remember she's taking 2 biscuits out, so is she putting the one back in again? No. So this is called without replacement. So what happens to the number of biscuits? If you have 20 biscuits in 10, you take one out, Isa, how many are left now? 19. So the next one's 19. So if you had 12 biscuits first, you take one out, how many got left now? 11. Okay? That's the probability of getting 2 planes. 12 over 20 found by 11 over 19. You happy with that? Okay, now similarly, let's do now probability of the chocolate ones. Let's do a different color again. Change color. Okay, now we haven't worked that out yet. Can somebody give me a quick calculation for that? Just give me a fraction, please.
33 over 95.
That gives us what?
33 over 95.
Happy with that, Isa? Got that too? Okay, now the next one, please. Let's work out the probability of getting a chocolate and the probability of getting a chocolate. The probability of getting chocolate biscuit is what? Chocolate biscuit is 5 out of 20. That's the first chocolate biscuit we take out. Now there's 19 biscuits in there. How many chocolate ones are left over? How many chocolate ones are left over? We're going from 5 to 4 out of 19. Okay, happy with that? Okay. So the probability for that should give us, is that 1 over 19 by any chance? Yes? Good. Right, next one. Isa, are you with me?
Yeah.
You happy with that? Okay, Isa, you have the next one. Probability of a ginger biscuit. Ginger. Okay. My favorite biscuits. After that's chocolate digest, obviously. Okay. So what's the probability of me getting my first ginger biscuit?
3 over 20.
3 over 20. Okay. Smee, what's the probability of me getting my second ginger biscuit?
Is it 2 over 19?
2 over 19. And the total number of ginger biscuit probability is?
3 over 119.
Who says
Okay.
that?
Okay, right. Okay, what have you got there calculation wise? Have you got, on the calculator we got?
3 over 190.
3 over 190, okay. Okay, good. Now, as we said in the beginning, we're going to use this technique to work it out. So, here we go. For the last part, let's choose a red. So what was the probability of getting the same biscuit each time? This, or this, or this. When we use the word or, what does the word or mean in probability? It means add. So we're going to do 1 minus 33 over 95, and we're going to add 1 over 19, and we're going to add 3 over 190. I think that's correct. Okay folks, can you put that calculation into your calculator please, and tell me what kind of calculation you get out of that. Okay, try that. Okay. Okay, folks, have you got your answers?
Yeah.
What you got?
111 over 190.
Lovely. What's the decimal version of that? If you press the SD button, what do you get?
0.584.
0.584 something. So we could say that would be 0.58 if you wanted to give it like a decimal equivalent. Okay, that's done. Lovely. Okay, are we moving to the last question now, Isa?
Yeah.
Done. Okay. Right, Isa, can you deliver us the next question, please? Right. Really nice one. Okay. Okay. OAB is a triangle. Now, so topic is on vectors. O to A is a small vector A. O to B is a small vector B. Let's find A to B. Right. I don't want just the answer. Let's look at it. I need to go from here to here. Now, Isa, can I go at the moment? Can I go just straight up? And the answer is no, because we don't have the information to go straight up. The vector's missing, so we have to go the long way. Okay, so I say I want to go from my area to another area, but I don't know the direct way, but I know a way through a different area. That's what we're going to do. We're going to do the back streets. So we're going to go this way and then that way, following the vectors, the ones that we do know. Okay, so now if I go this way, which is opposite direction of A, what will that be then? And if I go in the direction of B, that would be just normal B. Now let's have a look how we set it all out. So we say A to B, first we're going to go A to O. A to O plus, and then we'll go from O to B. O to B. Now A to O is opposite of A, so that becomes minus A. And O to B is in the direction of just plus B. Okay. Now we have minus A plus B. Some students like to just change it around and write down here there's B minus A. Whatever makes you happy, that doesn't make any difference to me. It's no problem. Okay. Okay, are you happy with that, Isa? And that's the first part of the question. So we worked out A to B in terms of A and B. Because P is the point on AB such that A to P. Okay. No, Isa, actually don't do it back down to the moment because we need to see the vector. Do it back down, take it back down. We'll cope with the take it back to the measure. Up, same as plus stop. Lovely. Okay, that's okay at the moment. We leave it. Oh no, I think we're off the screen, are we?
Yeah.
It's over here. Okay. Oh,
You can put it on again.
Okay. Right, I'm going to read the next part of the question to you and then we're going to write it up there, the working out. Otherwise we're going to lose the diagram. Okay, right. It says P is the point on the subside A to P. I'll just rewrite it for you over here. Okay. So that's going to be, that's worth 3 parts and that's worth 1 part. What's 3 parts and 1 part? 4. So A to P is going to be 3/4, isn't it, of A to B. Okay, at the moment. And then P to B will be 1/4, 1 out of 4 parts. So we say that is 1/4 A to B. Okay. This here itself is not a vector. Okay, let's just tell you the direction. The vectors are these little ones here. But for the moment, these will do for us. For us to interpret the information they've given us. They told us here that A to P, ratio P to B is 3:1. So that's worth 3 parts, that's worth 1 part, so we have 4 parts. So that's 3/4 of the way up, that's 1/4 of the way up. So that's how we interpret this. So this 3:1 becomes 3/4 here and becomes 1/4 there. Okay, that's how we interpret that. Okay, it says they find O to P in terms of A and B. So we got to go from O to P. I'll do that. Where's my border bar? Yes.
One.
Okay. Let's find O to P. So, you gotta work out that vector O to P. Right. Do we know? Do we have a vector for that at the moment? No. We gotta work it out. We gotta work out O to P. The actual vector there, we don't know what it is. Okay. Now, what do we know? We do know how to get from O to A. Is that right?
Yeah.
Do we know how to get from A to P? Yes, because that's 3/4 of A to B. We worked A to B in the previous question. Okay, so we can go this way and then that way. Should we do that? So again, we're doing the long route. Because we don't know how to go from here to here directly, we gotta go the scenic route. This way and then that way, and then the algebra, it will all simplify and give us the correct answer. So, let's have a look at that, Isa. Are you ready? Remember, we'll be reusing this. So let's write down what we're going to do first of all. We are going to go from O to P, and we're going to take the scenic route. Okay? That's not why I drive a scenic, by the way. This is because I love vectors so much. Okay, O to P, we're going to go from O to A, and then we're going to go from A to P. Right. As I said earlier, you remember I said to you earlier that that ratio 3 to 1 means 3/4 of the way?
Yeah.
So 3/4 of vector AB. Okay? So under this part here, A to P, I'm going to rewrite now 3/4 of A, B. Are you happy with that, Isa?
Yeah.
What is O to A, Nimra? O to A is? A. So that's already vectorized now. Okay, now A to B. What is A to B? What is A to B? What's A to B, folks?
Minus
B minus
A.
A. Or minus A plus B.
Okay, B minus A. Okay. Most students get to this stage and they had enough. Oh no, I've got fractions, I've got to multiply negative letters. It's time to find the exit and run for the door. Okay, nothing to worry about here. Let's multiply out the brackets, simplify it, and inshallah, hopefully we should get the right answer. So, just rewrite over here. A plus B B minus A. Let's make sure, is that copied up correctly, folks? Yeah? Right, here we go. Right, so A stays the same. Now, what's 3/4 times by B? 3/4 B. If I say to 3/4 times by letter, it's just 3/4 B, just put them back together. What is plus 3/4 times by minus A?
Minus 3/4 A.
Minus 3/4 A. Now, we need to simplify. You saw I have 1A. 1A is made of how many quarters? 4. I have 4 quarters in there and I take away 3/4. So how many quarters do I have left over? 1. So this part here and this part here gives you, and that part stays as it is. Okay, happy with that? Now, could we factorize that and make it a bit more neater?
Yeah.
Take the quarter out. And we'll be running out of video space soon. So we say take the quarter out of as a common factor, and we're left with A
Plus 3B.
Okay, Lisa, let's have a quick look at yours. Are we happy with that? Okay, is that the last question?
Yeah.
Any more?
No.
Okay, that's lovely. Okay, folks, sorry about this exam paper coming over into 4 videos rather than 3. We did have a battery failure in the beginning of the 3rd video, so that's why they had a 4th video. But that's all done now, so hopefully, I hope this helps you with your examination preparation. Remember, this is for the Edexcel 1 MAO, paper 2H, okay, the calculator paper. This was the 6th of June 2012 paper, and inshallah, hopefully we see you in the next videos for the next paper. We're going to try a November paper next, which is a bit more, I'll call it a bit more juicy. The students don't like that word, they know it means a bit more harder. But no, it's just a little bit more kind of a challenging is the correct word. Inshallah, hopefully see you in the next video on that. And until then, if you're going to break now for Salatul Asr, inshallah we're going to pray. Assalamu alaikum, see you next week then.